This is the Integrated 1 mini lecture for 9.1.3. So this has to do with that packet I gave you to, this is your homework during the testing weeks. And I mentioned it on the last video, I really want you to go in your book and actually read the problems in 9.1.3. Just, I know you don't have your team with you or anything, but you just read it, and so that you will understand why we are even doing any of this type of stuff. Because right now, all I'm going to do is just show you how to solve the problems. But if you don't read in your book, then you're not going to really know why we're doing any of this stuff. But so for now, I'm just going to show you how, though. So what we do is we have an absolute value. Hopefully you know what absolute value means. It's the distance something is away from 0 on the number line. So this is just saying that whatever quantity is inside these absolute value bars, its distance away from 0 on the number line is 11. Okay, absolute values are never negative. Like you might have seen this before. What's the absolute value of negative 5? Well, you would say it's 5, right? Because on the number line, the distance, however many jumps it takes me to get to 0, the distance between negative 5 and 0 is just 5. So that's kind of the definition of what absolute value is. So if you're doing algebra and you want to get x by itself, you got to get those absolute value bars to go away. So the way to do that is we don't know if this quantity in here might be negative 11. You know what I mean? Because the absolute value of negative 11 is the same as 11. So this could be positive 11 or negative 11. So I like to break it up into the negative case scenario and the positive case scenario, and it shows how to do it in this packet that I'm giving you too. This is how I do it. So when you do it the negative way, you just go 3x plus 2, and then you just make the right hand side of the equation negative. And then I usually make a squiggle mark to separate them, and then 3x plus 2 equals positive 11. And I just solve it using my algebra skills. I want to subtract 2 from both sides. And I would like to divide by 3, and that gives me x equals negative 13 thirds. So that's one of my answers. And then subtract 2 on both sides, that gives me a 9. 3x, divide by 3, and x equals 3. So there's my two answers. Okay, and then you can go in the back of the answer, like in the back of your packet. You can check them. So it's negative 3 or negative 13 thirds. And if you're wondering why is it two different things, you can plug them in and look. Now I know absolute value, whatever's inside these bars better be 11 or negative 11. Or else this thing isn't true. Well, if I put the 3 in, 3 times 3 is 9 plus 2, that gives me 11. And the distance that 11 is on the, if I were to put an 11 on my number line, its distance away from 0 would be 11. Also negative 11. So if I put this in there, I'll bet you I get negative 11. See, like if I multiply, if I put negative 13 thirds right there for x, the 3's would cancel out and I'd have negative 13 plus 2. Well, that's negative 11, and the absolute value of negative 11 is 11. So you can always check these. Okay, so 2, the answer was negative 13 thirds or x equals 3. And then I was planning on doing number 5. Now, number 5 is interesting. Number 5 is very interesting, and it won't take us very long. Sometimes these fool me. I don't want them to fool you, though. It's this thing is telling me that there's an absolute value of something that's equal to a negative number. And I know that just by the definition of what an absolute value is, that there's nothing there's no numbers I could stick in there and then take the absolute value of them and come out with a negative. So we just write no solution. So be looking out for stuff like that. There's no solution because Okay, well, let's say that's negative 7 in there. What's the absolute value of negative 7? Well, it's 7. There's no negative number that you can stick inside these absolute value bars and have it be equal to a negative number. So that's why I'm saying that's no solution. Now, number 7 wants you to do, we're going to do absolute value with an inequality symbol rather than an equal sign. So it's going to be very much the same procedure. There's just a little bit different. So this is saying that an absolute value of something is greater than 7, or in other words, it's more than 7. The distance from 0 on the number line of this is greater than 7. So it could be or greater than or equal to 7. So it could be 8 or 9 or 10 or negative 8 or 9 or 10 or something. So we're still going to do the same procedure on there. We're going to write the negative way and the positive way, as if this quantity were negative and as if this quantity were positive. So the way you do it here, though, because of the inequality, is you're going to, for the negative way, you're actually going to flip the inequality so that it's reversed, so it's going the other way, and turn the right-hand side negative. And then when you do it the positive way, it's just, now you can read in your book if you need to know more about why we even did any of that. I'm just kind of showing you how. You reverse the inequality symbol and you decide negative, and then you solve it. And then this one, see, all we did was just wrote the problem down with no absolute bar symbol, or absolute value bars. And then we go ahead and do our algebra. I think it's negative 11, and that's going to be x. So that's part of our, and then minus 4, so I guess that's going to give me a 3. Okay, so x is less than negative 11, x is greater than 3. And let's check our answer. Yeah. You should write an or in there. See, if you look at your answer, I usually try to remember to write an or in there. Number 7, see, it's greater than 3, or x is less than or equal to negative 11. So I want to have time to do number 14. Number 14. Oh, number 14 looks a little bit interesting. 5x. This number 14. I try to just do the ones that are the most interesting. Okay. Can an absolute value of something be greater than a negative number? Well, we know it can't be a negative number because we found that out when we were doing this one up here. We found out it can't be a negative number. But can it be greater than a negative number? Sure. Basically, any number that I stick in here, when I take the absolute value of it, even if I put a number in here that makes this whole quantity negative, once I take the absolute value bar, or once I take the absolute value of it, it's going to be positive. So basically, this has to be a positive number. So any number that I stick in here is going to be greater than negative 15. Okay, so in other words, this is all solutions, or infinite solutions. Let me see which way your book writes it. They want us to say all real numbers. Let's just say that, all real. So if you look in your answer key, it says all real numbers. If you said all solutions, that would be okay too. All real numbers. Why is that? Because the distance away from 0, the absolute value, it's going to be positive. And so then a positive number is greater than a negative number. Well, yeah, any number I stick in there is going to give me greater than negative 15. So that's why that one was actually so easy. Here's number 15. You know, I'm going to do number 15 and number 17 on a separate video because I have a time limit on my YouTube. So tune in for part 2. It'll be a separate video.